I'd like to start by asking a question. What is the sum of the first 30 positive integers? So we'd write this in summation notation as the sum from k equals 1 to 30 of k. Nowadays, you could just type in all the numbers and add them up and get the computer to tell you the answer. Even better, you can use the math input on Wolfram Alpha. You can actually use the sigma notation and it will give you the same answer. So we see that the sum of the first 30 positive integers is 465. Let's look at how we could calculate this sum of positive integers from 1 to 30 without a computer. So we're adding 1 plus 2 plus ... up to 30. The key idea is that we want to divide the numbers that are being added into pairs. The first pair we're going to look at is 30 plus 1. So we take 1 and 30 and we add them together and we get 31. Then we can look at the next pair, which is 2 and 29, and that pair also adds to 31. And we're just going to keep doing this, pairing the numbers up, and each pair that we get adds to 31. And the final pair that we're going to hit is this middle pair of 15 plus 16. So we divided our numbers up into pairs, each of which adds to 31. So the next question is, how many of these pairs that added to 31 were there? And we can look and think about it. Okay, there's 1 for 1, 2, 3, all the way down to 15. So there are 15 total pairs. We have 15 pairs and each pair adds to 31. So the total will be 15 times 31. So let's cover a new definition. The nth triangular number, which we denote Tn, is the sum of the first n positive integers. So for instance, let's look at the first triangular number, T1. T1 is just 1 because I just add the first one positive integer. T2 is going to be 1 plus 2, which is 3. And T3 is going to be 1 plus 2 plus 3, which is 6. Now you'll see I have these diagrams where I'm just looking like I'm stacking boxes here. And this suggests why these are called the triangular numbers. So I want you to do T4 real quick for practice and see what you get. What's the fourth triangular number? The sum of the first 4 positive integers. If you actually do it out, you'll get that the answer is 10. My diagram is going to look like this, and I'm going to have 1 plus 2 plus 3 plus 4. So I could do this all day, but what I'd like to have is a more general formula that will allow me to just tell you the answer without having to write out all of the pluses. To get this formula, we want to think geometrically. So I'm going to draw my triangle diagram here from 1 to 5. And then I think, well, what if I could turn this into a rectangle? And I want it to be that the triangle area that I had is half of the rectangle. Now, if you look at what I've done up to here, I actually don't have enough information. This isn't quite half of the rectangle. So what I need to do is add another column. And now the shaded area is half of this rectangle. So let's look at the rectangle. The rectangle is n blocks high. In this case, n is 5. And it's n plus 1 blocks wide. So the general formula for this is going to be, when I have 1 plus 2 up to n, it's 1/2 of n times n plus 1. Because this shape that I had, the overall blue shape, is an n by n plus 1 rectangle, and the green shaded area that my sum represents is half of that. So it's 1/2 times n plus 1. Now, if you just need the formula, you could memorize the formula. But I think it's really cool to know where the formula comes from so that you can rederive it and actually think like a mathematician.